Hello, welcome to the third lecture of ARCHLine.XP Intermediate course, the Importing Architectural Plans workshop. Let's get started. I'm starting a new project. We can import the floor plan provided by the architect into the program and then use it to create the 3D model. The creation time depends on which method we choose and the format of the imported file. The floor plan can be an image, PNG or JPG format, a PDF, geometry or raster image. We can also import a DWG drawing, an IFC model or a Revit file. Let's start importing the image. When the floor plan is visible as a raster image in which architectural elements are clearly recognizable and the image contains few other types of elements, this clean floor plan can be vectorized. In this case, we recommend using the blueprint method, which allows you to convert a floor plan provided as an image into a 3D model. If the image containing the floor plan is not clean, meaning it contains many elements beyond the architectural components, we suggest using the import a floor plan as an image method demonstrated in the next section. Let's look at the case of a clean floor plan. Vectorizing raster image floor plans allows for converting a scanned floor plan into vector drawing, then into a 3D model. After importing the raster image, ARCHLine.XP automatically performs the vectorization, and the result can be placed as a group anywhere on the floor plan. Next, the vector drawing needs to be calibrated by setting a recognizable measurement. The generative floor plan command interprets the 2D group and converts it into a 3D model, containing walls, doors and windows. In the first step, I select the building menu, blueprint, from raster image, image vectorizer command. I select the importing architectural plans, then JPEG folder, and import the office PNG image. Make sure the DPI dots per inch value is between 300 and 500. If you import an image with a lower resolution, it will likely result in a pixelated scan. I place the image near the origin in the floor plan window. The program automatically performs the vectorization, then displays the elements of the vectorized group, lines, polylines. Place the group as well. In the second step, I scale the group to the actual distance. I select the group, press the Enter key. I specify the distance with 2 points and assign the new physical distance to it. Then always check that the correct dimensions have been created after scaling. In the third step, I convert the lines into walls using the generative floor plan command. The process of converting lines into walls and openings is automatic. In the dialog that appears, I set the desired threshold values. Then I select the group. The 3D model is created. In the fourth step, I adjust the architectural elements. I delete unnecessary walls, connect the necessary ones, and place the missing openings. In the next section, I will demonstrate the importing floor plan as an image method. This method is recommended when the image containing the floor plan is not clean, meaning it contains many elements besides the architectural ones, making it difficult to recognize the architectural elements. In this case, the previous blueprint converting floor plan from image to 3D model method cannot be used. Let's look at the importing floor plan as an image method. In the first step, I import the raster image using the File menu, Import Raster Image command. I select the Importing Architectural Plans, then JPG folder, and import this image. In the pop-up dialog, the properties of the image are displayed. We can change these, of course, but what is important to check is what kind of layer the image will be placed on. This will be on the raster image layer. I accept the settings and then place the image on the floor plan. It is always recommended to place it close to the origin. After the first click, pressing Enter will place the image at its original size. The imported image is not scaled, so we need to calibrate it. Let's calibrate it. I click on the image and choose Calibrate from the local menu. I have to select points of the picture that I know. For example, let's look at this dimension line. I zoom in. Select its first point, then the second. I have to write in the actual size. I accept it, then check the accuracy of the calibration. This time selecting the Measure command from the quick toolbar. Let's see if the calibration was successful. It is also advisable to check a dimension in the horizontal direction. I can see that the picture is a bit angled. I will correct that. I draw a vertical line using the Drafting Line tool. I start from this corner point and draw the line upwards. The green guideline will help me draw the straight line. We can see the reference and the red auxiliary line form an angle. Clicking on the image, I select the Rotate marker and within that the Rotate from option. I select the center of rotation, then the first angle leg, which is the end of the reference line, and then the end of the auxiliary line. Now the lines overlap completely. I delete the auxiliary line and I start working on the plan. I start by drawing the walls. Let's set the properties of the wall. I right-click on the Wall command and select the Properties menu. I rewrite the wall thickness to 200 mm. I click on the name of the current style and then on the New button and save it as One Layered 20 Wide Wall. I select it to be available in all projects. So we will be able to use this wall style not only in this project, but in all our future projects. I activate the style and start drawing the walls. We can switch to another wall style from the side menu at any time. Always pay attention to the position of the wall reference line, which is marked in blue. We can change this in the menu above or by pressing the space button. I start drawing the walls. If we know the length of the wall, we can write it in, or we can simply draw around the floor plan. By pressing Shift button, we can lock the direction. This will help us with the editing. I'm back to the start point, so I finished working on the first plan. Let's have a look at it in 3D. Our next topic will be importing PDFs. Let's see how we can distinguish between the two types of PDF. There are two PDFs in the course folder. Let's look at the first one. Zooming in, I can see that the lines are broken up. This means it is a PDF as an image. If we look at the second one, the drawing is clear, even after zooming in, so it is a PDF geometry. Before importing, it is definitely worth checking which version we will be working with. I go back into the program and open a new project. I import the raster image PDF first. The PDF import properties are displayed. First, I have to specify whether this file is a raster image or vectorized. I select raster image. I then need to set the resolution. It is advisable setting a higher resolution to get a good quality image. If we have imported a PDF with multiple pages, we can choose which page to use. I accept it and place it near to the origin. After the first click, I use Enter to place it at the original size. We need to calibrate as we did with the previous picture. Right mouse button, Calibrate command. I enter 2 points and then distance between them, which is 4200 mm. I also check the accuracy of the calibration. I got the right value, so I worked accurately. Then we can start processing the plan in the same way as we did for the image. I will not repeat this now. I'm starting a new project. I use File, Import PDF command and select the second PDF. I choose to vectorize the data. I can set whether to display the solid fields in the PDF after importing. If so, I can convert them to hatching. I can set to apply line weights too. This means that the program can handle line thicknesses from another program. We won't deal with this now, so I'll turn it off so that we only see one kind of line thickness. Also, I will not display the fields. I can also set which page I will use in case of a PDF with multiple pages. The preview of the floor plan appears, where we have to set the scale factor with selecting the units of measurement in which the file will be imported. The ruler will help us with this. We can see that the floor plan is only 20 meters wide. I accept the settings. I press OK. I start with a measurement here too. Let's look at the length of the outer wall. There is almost 40 mm difference between the plan and the reality. I'm not going to correct this by calibration, but by scaling. From the Edit Move menu, I select the Scale option. I need to select the group to scale. I press Enter to accept and specify the scaling center, which should be the bottom left corner of the group. I can also specify the amount of scaling graphically, but I will enter a value in order to ensure accuracy. In the floating menu, I click on Scaling and then type the value command. I enter the scale using the measurement I just made, so I enter 1377/1373. I don't need to calculate this. The program can handle the formulas. I accept. I will make a control measurement. Now the size is correct. I've already mentioned that it's a group. By selecting the local menu, I can edit the elements of the group. I can delete a line or add new lines. After editing, the group must be closed using the local menu, Close Group command. The PDF has been imported, so its elements are on separate layers. Let's look at this in the Layer Manager. We see its layers at the Layer Filters section. However, if we look at the PDF itself, it will be on Layer 0. It can be distracting to be able to select a group when working. Let's look at how we can lock this down. The elements of the PDF are not on the layer 0. We have the possibility to put all elements of the PDF on one layer. And then click on the PDF to turn on the Force Layer option. Going back to the Layer Manager, this is already locked, so I won't be able to select the group. Let's start creating the plan. The thickness of the wall is not dimensionized on the floor plan, but that's fine, because we can take advantage of the property of the geometry PDF. Using the Building Wall Walls command, I can very easily draw around the floor plan. First, I need to specify the point near the start of the wall, then the point near the end, and finally the thickness of the wall. This is how the first wall is created. I'll draw all the others. I select the point near the start, the point near the end, and the thickness, so I can create walls easily with 3 clicks. It is okay if the walls are not connected. I can modify them afterwards with the wall connection commands. Here I choose L connection. I specify one wall, then the other, and I just connect them. By the way, connection walls work in 3D as well. Just like I did in the 2D view. I select the first wall, then the second wall, and I'm done. Now let's look at how to make a niche. I choose the component mode and insert 4 nodes, which I align to the right points. The niche is done. The next step will be to install the windows and doors. I will start with the door. I don't need to preset its dimension in the Properties window, as I'm going to place it graphically with 2 points. I will specify the first point and then the second point. With that, I've specified the width of the door. I still need to specify the opening direction. Next, I place windows. I also change the distance from the wall to 400 mm. I select the option Window by 2 points. The window should always be placed on the inside of the wall. I place another window. I won't be able to place this on the inside wall as there is a chamfer here, so I'll place this on the outside wall. Let's look at in 3D why it's not a good idea to place the window on the outside wall and how we can change it once we placed it there. The first window is in place, but the second window is facing outwards. I will have to mirror this. I can mirror it here or in the 2D. Let's edit the window chamfer. I click on the window and choose Local Menu, Wall Connection, Complex Editing. It's important to select the window near the inner side, because if we select the near outer side, I will edit that. The edit line now appears on the inside. I insert a node as the line is straight up to the center of the wall, and then move the endpoint to the correct position. I accept with Enter. I do not edit the other side, but simply mirror this one. I select the left side of the chamfer and then select the mirroring option. Done. This completes the processing of the geometry PDF. In the following example, we will create a 2-story building based on a DWG drawing. We received the floor plan in DWG file from the architect. Importing the DWG file also means a geometric import, so the result will be dimensionally accurate vector drawing. We will apply the blueprint feature to this. The blueprint feature automatically generates BIM models from DWG floor plans. This intelligent tool interprets 2D drawings and transforms them into 3D models. The algorithm reviews the drawing, analyzes it based on the specified wall and opening limits. In the next step, it transforms these into real architectural elements, creating walls, doors, and windows. For CAD drawings, the algorithm can achieve a 90–95% recognition rate. The process consists of the following steps. Import DWG drawing. Convert the drawing into a local group. Generated floor plan. Convert lines into walls. Let's begin. First, I select the building menu blueprint from DWG import command. I select the file. I deal with the ground floor first, so that's the one I will choose. The preview appears. Here again, I need to set the unit of the measurement. I accept it and then place it with the new drawing origin. Let's check the size of the drawing. I measure this dimension line and I see that I've measured the same, so there is no need to change it. Even though I placed it near the origin, the architect in the other program specified the reference point that is not near the building, so now the building is far away from the origin. On the right, the running coordinates show the distance of the given point from the origin. A large distance from the origin can cause calculation inaccuracies. We just faced that the floor plan is far from the origin. In this case, I can use Edit, Move, Relocate Project Origin command to move the origin to the selected point in the drawing. I specify this point and accept it. The origin has been moved. We can also see that the distance is reduced in the running coordinates. We can significantly increase the accuracy of blueprint algorithm by only leaving the layer related to walls turned on. Using the Layer Wall command, I activate only the walls layer. On the floor plan, I select the dimensioning for the openings and move it to the dimension layer, which I then turn off. Now only the walls and openings within the walls are visible on the floor plan. In the next step, I convert the drawing into a local group by selecting the building menu Blueprint from DWG Create Local Group command. I select the entire drawing and the group is created. In the third step, I use the Generative Floor Plan command to create the 3D BIM model. In the dialog that appears, I specify the limits. The algorithm reviews the drawing and analyzes it based on the specified wall and opening limits. During the review, it filters out unnecessary content and searches for patterns in the drawings that can be reliably identified as walls, doors, and windows. It then transforms these into real architectural elements, creating walls, doors, and windows. After closing the dialog, I select the local group and the 3D model is complete and ready for refinement. I draw the missing walls, applying T and L connections. I add the missing openings using the door or window by 2 points command. Finally, I draw the slab. After turning off the wall layer and placing the opening dimensions, we get the following result. From these two windows, I will create a corner window by going to the local menu, Edit, Join two openings on the wall corner command, and selecting the second window. The corner window has been created with the windows shifted to the wall corners. As a small detail, it's worth reviewing the line thickness display on the screen. In the View control bar, clicking on the line weight scale allows us to choose from different line weight scales. The line weight scale applies to the screen and does not affect print settings. The default line scale is set to 1:20. For example, if you want to print the plan later at a 1:100 scale and also see the corresponding line weight on the screen, choose 1:100 scale. Non-line weight scale means that the program displays the line thickness on the screen at the smallest weight of 1 pixel, effectively turning off line weight. This setting is particularly useful for floor plan editing, as the clear visibility of endpoints and other special points makes precise editing easier. I go back to the floor plan and turn back on the other layers. I go up to the first level and import the second DWG file, which is the floor plan of the first level. Here is another method. Opening the file manager, I simply drag the floor plan to the first floor. In the preview, I have to specify the unit of the measurement. I accept and place it with the new drawing origin. The same thing happened as with the import of the ground level, that the plan is very far away from the origin, so we have to correct it again. So I need to correct the distance from the origin. I can't use the Replace Project Origin command here, because then the floor plan on the ground level will slip. Therefore, I have to move the floor plan itself to the origin. In the lower status bar, I select the absolute coordinate input and then select the entire floor plan. Then click on the Move marker and select the Move From command. I select the same point that I specified as the origin on the ground floor and then enter its coordinates, 0, 0. I accept with Enter, and the selected point on the drawing is moved to the origin. Let's check that the levels are correctly aligned. Then go down to the ground floor. In the Layer Walk window, I display only the layers containing the architectural elements, so the slab and the walls. I accept it. To avoid having to redraw the walls and the slab on the first floor, I select the floor plan and choose Copy to another level in the Level Manager. I choose the first level. In the 3D view, we can see that it has been copied to the first floor. Then, based on the floor plan, at level 1, you must adjust the walls. Delete the walls that do not appear on the first level. Move the existing walls to the drawn position to speed up the work. Then apply the T and L connections. Using the Blueprint feature, we can quickly and easily create a multi-story building from a DWG floor plan. We will now look at the import of the IFC model. For this, I will open a new empty project. ARCHLine.XP is IFC Coordination View 2.0 import certified design software. Thanks to this, we can get floor plans and 3D models at a higher standard from designer using other software like ArchiCAD, Revit or ALLPlan. The Industry Foundation Classes IFC Data model was designed to describe building and construction information. The IFC format is universal, neutral data format, considered standard for industrial data exchange today. ARCHLine.XP supports both IFC4 and IFC 2x3 for import and export. It has an IFC 2x3 coordination view 2.0 certification. IFC provides 3D geometry and data exchange between different CAD BIM design software. The most valuable property of the IFC format is preserving architectural elements and properties. The properties of elements, like walls and ceilings, remain unchanged, though some compromises may occur due to the current technology levels. IFC-based data exchange has a much larger capacity than the more widely used DXF DWG-based data format. Let's look at when we receive the project as an IFC model. I choose the file Import IFC command. The program offers 5 options. 1. Open a new project file, import the IFC model, and continue working on it. 2. Add the IFC model to the current project as a separate, editable structure. 3. Link IFC to the current project as an external reference. 4. Import the IFC model to the current project in a new view window, suitable for comparing states or for later using a part of the IFC model by copying it into the floorplan view. 5. Convert IFC file content into a single object, useful for furniture objects downloaded in IFC format. In our case, when we want to load a floor plan as an IFC, we need to use the first option. Select the IFC file. The style names stored in the IFC file appear in the Style Manager. You can specify how and when styles are created. Create empty setting and add new ones. In this case, ARCHLine.XP default styles are deleted and the project contains only the styles imported from the IFC file. Keep ARCHLine.XP default styles and add new ones. In this case, ARCHLine.XP retains the default styles and adds the styles imported from the IFC file. Select the second option. The project keeps the default styles. You can select what to import from the IFC file, all or only architecture or only MEP pipeline elements with or without geometry conversion. With original geometry, this means the model retains the geometry it was originally created with, and the elements are created in ARCHLine.XP as IFC element types. When exporting, the same model received can be returned to the co-designer supplemented with the user's own model. With geometry conversion, this means the architecture elements like walls, slabs, doors, windows, columns, beams, and terrain are converted into corresponding ARCHLine.XP elements, walls, slab, etc. If the original model is very complex, walls, slab, and so on, may become IFC elements due to non-corresponding complex geometry. Railings, stairs, and roofs can only be created as IFC elements. Filters. In the Filters window, you can individually select which elements types to apply or not to apply conversion to. Choose the Architecture with Geometry Conversion option. After importing the IFC model, the entire floor plan and the 3D model will be visible. It's important to note that the model and its floor plan imported from IFC do not contain drawing elements, such as dimensions or labels. The model retains its original scale, so no scaling is needed in this case. Another key difference from other imports is that the model imported this way retains the original layer and level structure of the design. We can check this in the Layer Manager and the Level Manager dialog windows. Let's make some changes to this model and see how we can do them. I'm going to change the height of this retaining wall. I click on it, select the top left node, and use the Change Height command to modify it. Let's place windows on it. After the command Place Window, I select the wall and then place them. Let's place another window in this wall using the same command. As we can see, the window is placed, but there is not a cutout, even though it worked well before. I click on the wall and look at its properties. 3D fixing is enabled. This means that it has been fixed in the other software. If a wall is too profiled, it is an option to export it as an IFC element or to fix the 3D representation. If I turn this option off, the window cutout is already displayed. However, the height of the wall has changed. I can correct this by using the height adjustment command to pull it back to its original position. I can also create perspective, just like with ARCHLine models. Let's look at an example. I create a view from here of the terrace. I save that, and then I select the front view and create a view from upstairs. I can switch between views in the same way. Let's change the material of this wall. I click on it, and in the Properties menu, I click on the interior color. Importing IFC allows us to download real walls, slabs, and other elements from a code designer using another software, then edit them as real walls, slabs, and other elements. Finally, we can pass on the completed plan as an IFC file to code designers, so they can work on it with the convenience using another software. Now we come to the last topic, importing Revit files. I open a new project and import the RVT file. BIM collaboration between architects is based on fast and easy model exchange. Revit RVT models can be used with ARCHLine.XP in two ways, conversion and linkage. Now we import it as a separate file. ARCHLine.XP converts original Revit walls, slabs, columns, and beams into ARCHLine.XP walls, slabs, columns, and beams. All other elements are converted to IFC elements. In addition, we can import doors, windows, objects, and MEP equipment from RFA files into ARCHLine.XP. I import as a conversion using the File menu, Import RFA RVT command. This will be the same model that was in the IFC file. In the Import Settings window, I select the second option, Native RVT RFA Reader. Revit imports often refer to materials in the Autodesk Material Library. The Autodesk Material Library is a free installation package that includes images for material display. In case the Autodesk Material Library is downloaded to the computer, the model will be displayed with textures. These textures are included in the Revit file for reference only. At the end of the import, a dialog box displays the statistics of the imported items. Here we can see which architecturals and IFC elements have been imported. I press OK. Let's look at the 3D model. If we click on this architectural element, we can see that it is a wall. Let's look at its properties. We can see that this is a layered wall structure, and if we click on the layers of the wall, we can even edit them. We can also change the height of the wall and its materials. Revit family appear in the program and are available as ARCHLine styles with the same properties. Clicking on the Wall tool in the side menu will display Revit families as styles in blue. These will also appear for all architectural structures, such as slab. Another big advantage of importing Revit is that the level structure is also manageable. I show it in the Level Manager. We can also import doors and windows from RVT and RFA files into the program. For example, take a look at beamobject.com and let's download a door from here. You can also download objects from here only after logging in. I select the doors and filter them down to the Revit files. I choose the brand ARCHLine and download the door. I use the file import command to download the door. Here we also get the statistics of the imported items. I choose the 3D window. I right-click on the first door and choose Convert Object to Door Window option. I need to align the wall connection points to the corresponding points on the model. Clicking on them will automatically detect the endpoints and help us find the correct one. Follow the help table on the right to determine the points. I save it to the library under the name ARCHLine1 in the Outdoor Others category. This way I can save an entire product line. Now I'm going to open a project, a model used in the visual design workshop. In it I will place the saved door. I activate the 3D window and from the Design Center I select Building, Door, Exterior, Other folder. I change the view and place the new door on this wall behind the dining area. I select the option Place it from wall endpoint, select the surface and then specify the door location. Clicking on the pencil icon, I can change its properties including material, width, height and other parameters. Thank you very much for joining me for this video. I look forward to seeing you at the next workshop. Until then, have a lovely day. Bye-bye.